this side is facing southwest, this side is facing northeast, right? So just for your information, guys, you guys will have these. I stressed these on the upcoming slides, but the idea is that this north side, this generation of energy, are separated from the south side generation of energy. So what you guys will see is that, thank you. So what you guys will be able to see is that this amount of solar panels here goes to that small room of inverters, and this amount of solar panels here deliver into the inverters inside the factory. Okay, that's why you have this not so much homogeneous space utilization. Okay. Okay, so so you have two POCs. Okay, the total amount of energy that you will be able to generate on a year is 2,281 megawatt hour a year. That's the 13 inverters generating energy, less in January, less in February, more in the summer, you know, but the total lump sum of energy, okay? So we build up the system based on the D1 net metering, and that has been according to the Solar NOC 838 and to the design approval 44858 and based on the DWC work permit here, okay? So this is the power flow, right? So solar DC energy produced on the solar panels, okay, arrives to the inverters. Inverters change to solar AC energy from solar panels. We combine them, everything into switch gears and electrical setup and whatsoever. And then we export or import or whatever, we use the energy in our facility, okay? That's the nutshell view, okay? This is in more detailed what you have here. So we have two POCs, 2 points of connection. One with 1,440 panels, the other with 3,240 panels. This is the factory one, the warehouse one. And this is the one for the archive room, yeah. Okay. So one has a 468 kilowatt peak, 400 kilowatt AC. The other is the double, 1053 with 900 kilowatt AC. Okay. This is a typical single line diagram. Okay. So you have the roof level where you have your solar panels and all that stuff. Actually, this line should be here a little bit above because you have the inverters here. The inverters are already ground floor. So this line should be above, okay? This is only for one of your systems. Since you have two separate systems, you have two SLTs, right? Then you have that combination box. This is your facility already. This is your LV panel 2 in the substation, okay? So what we are doing is we are combining all the outgoings of these inverters, bring it here, and then delivering to the same panel. The transformer of DO is here. Okay, this is your load, chiller 1, chiller 2, spare, capacitor bank, all that stuff. Okay, and this device here is the one that helps you to isolate the system from the grid. Okay, so what you have here is what I referred to you before on the last notes, the graphs saying that during the day your system generates more than what you need, so you can export that. So therefore in the night, you consume and you level it out, all right? So this was the energy simulation that we did based on the azimuths, on the material that you guys used here, on the inverters. You can see that there is three numbers that you should pay attention. One is the total amount of energy produced on a yearly basis. So if you come to this schedule here, energy to grid, in January 143. But in July, 234, okay? So that is the graph I designed for you later before. This is the graph, energy graph. In the summer, you produce more, but if you see in terms of efficiency, it's the opposite. In the summer, your efficiency is less, and that's related with temperatures, okay? So even though in the summer, your days are bigger, that bigger days, bigger sun hours, so you can generate more, but in terms of efficiency, if these temperatures are higher, then you lose efficiency. You don't lose energy, you lose efficiency, okay? This is an outcome of your communication system as it is now. Remember when I said to you guys about voltage, we can go up to 960 volt VOC if we put 20 panels in a series, all right? This voltage here is the inverter operating already. You see 31 kilowatts operating, though the voltage of string 1, string 2 channels, this is channels, okay? Channel 1, channel 2, channel 3, okay? Remains 734, 698, 672, all right? This is VMP. These numbers, if the inverter is operating, connected, there is no warnings, all active events are checked. This is a you see numbers here means that your inverters are generating energy, okay? This is VMP. If the inverter is dead, means no output or you're not connected or something, what values you should be able to see here are the VOC values, okay? And this, I will tell you guys how you guys can access it now, as of now, inverter level, all right? But the idea is to get all the inverters into the same house, and the same house shows this dashboard for all the system, okay? Okay, this is more what I've told you before, right? These solar panels facing north are delivering the energy to the archive room. The south ones are delivering the energy to the warehouse, all right? And you remember when we told you, you guys will have these drawings on as-built setup, okay? Remember when we talk about strings, 20 strings, we have 234. So what you see here is a 20 panel in series string. So we identify it in colors. So there's a blue color is a string 1. The green is string 2. So one day, if you go back to your inverter here and you say this channel 1 is affected to strings XYZ, if you have a problem, then you can start narrowing and be able to figure it out what could be the issue. All right? So what you see here is also the mounting system, but this has been based on a mini rail solution, and this is the clamps. All right, there is clamps here. Then we hook the clamps and we fix the solar panel. So what you see here from the side view is the clamp, the fixing bolt, the top PV clip, and the solar panel. Okay, and this is already your ground floor only, not level 1, ground floor. You have your warehouse ones and inside the room. Now we are going here, all right? But your point of connection is here at the moment, and this is your archive room. And here the point of connection goes to trenched LV room level. A simple list of equipment, contacts, okay, and that's not much more than this. These inverters creates a Wi-Fi network. Each single one creates a Wi-Fi network. And the MAC address is the Wi-Fi number, name. You see, this is the Wi-Fi name. In the password, the dash also comes. You need to put the dash also. Okay? 2, 3, 4, and 5, and 6. Okay? And each channel has a combined voltage now of 653 volt. Okay? All right? Now, if Ruben goes here, press here, for example, here, right, you will see the AC generation today. You see that is not linear. Right? Because some clouds could be there. Yeah. All right. Something could happen. Some clouds could affect the input one. And that has an effect on the output of the energy, right? So, though you can connect 7 days now. Can you put 7 days now? And that's the resume for the last 7 days, okay? Okay. Now, the idea is that later on you guys have all the information centralized on this box, but for that we'll create another session, yeah. Okay? Because that's bits and bytes. This is electrons, okay? But what I would like to share with you guys is this. some basic equipment you guys may have with you, which is gloves, stuff for the eyes, the normal PPE electrical stuff that you do know. But in terms of measuring tools, I would recommend you guys to get a 1000 volt meter, DC meter, and a clamp meter. The clamp meter could be your normal clamp meter that you guys usually hear on your operations, all right? Because the maximum current that we will have on these machines, on these panels, is only 10 amps, right? We don't have infinite currents. Because our solar panel, even though you short the panel, you cannot get more current than what is stated there. Unless you put the panel outside the planet, which 1000 volts is no longer applicable, but you have 1500, then the current will be respective proportional. Okay? Anyhow, but that will not happen. So the things has been identified. All right, so these numbers then you'll have on your shop drawing, so you guys will know where is the location of this string. Okay? Now, a simple feat now. Procedure shutdowns. We will do that on a separate session, okay? Because now we are running the harmonics, and the harmonics we cannot shut down anything. We need to keep it running, okay? But if I want to shut down the DC side, right, I just need to rotate these two switches. Okay, so what does it happen? Now the system is running on VMPP. If you measure any voltage here, you'll measure VMPP, correct? Because the system is under load. If I close these switches, then whatever voltage you get, it will be VOC, right? And you are only authorized to touch and remove connectors and touch here and open stuff if you are sure that the inverter is off. Okay? Because if now the system is under load and you guys come here with the switch and you remove it, since there is current flowing, can you imagine a pipe of water? If you put a grinder on a pipe of water with water running, what's going to happen? Some water will come. The same on electricity, right? You have an arc, right? So if I plug this now and I push it slowly, I will have an arc. And these arcs can go big and could catch you, could jump in your whatever, I don't know. At the same time, if you do that, you will lose the warranty on your machine. Because if you look at this side, you can see that says, do not disconnect under load. Okay? So if I have to give you an advice, my strongest advice would be making sure always that you don't have current circulating. Because this is the minus, this is the plus. All right? So current is now arriving here, going to the bus bar of the DC side and going back again. So you have a circuit closed. And when you have a circuit closed, never open nothing. You need to make sure the circuit is open. And how you make sure the circuit is open? First, off, clamp meter. Clamp meter here measuring. Current 0 on the meter. I'm safe. Go. Okay? This side is the same. You have the isolate. This is the DC switches. This is AC isolator. So one way that you could also replicate for safety operation of these machines is off isolator, okay? If you want to work on the DC side, off isolator, off DC switches, measurement tool, 0 amps, go, work, okay? Are you with me? If you want to work from this side to this side, then here is not enough, because your cables are here. Your cables are here. Okay? So what's going to happen is that if you isolate here, you still have potential on these cables. So you need to go back to that panel, isolate the panel, the machine in the small breaker, and you're good. If you want to do work from that main breaker to the dual side, You have to switch off the rest of the system. Are you with me, guys? Okay? And what I've told you here, it's the same for the others. In this room and in that room. Okay? And that's the most important part of it. Because even though the current is 9 amps, it takes 1 amp to kill a person. Less than 1 amp, you can kill a person. All right? So if you're not good grounded, this amp will travel through you. Right? Correct? And if you are a left-hand guy like me, which the left hand is always the one to go first, right? Then the heart is on the left side, right? So then I will be in troubles. Because if I short here and do this, then travels like this, right? But if I don't have this, possibly goes like this, yeah? Because the objective of the electricity is to reach the ground level. It will try to reach the ground, wherever it is. Could be in your electrical room, could be in somewhere, you never know. So that's why I'm focusing, guys. And a short on the DC side is always not much likely, but I would like you guys to take note on this, and that's why I never tired of stressing this out. Never short, never open these under load. First point. And if you want to open under load, make sure that you cover your back because you will lose warranties. And these connectors will burn. Okay? Okay. That has been said, okay? Then imagine you are open circuit voltage. The idea is the following. Since if you see the design, the male connector is different from the female connector. That's what allows us in the roof for you never put panels in parallel. Because if I put a plus to plus, then I'm doing them in parallel. Correct? If I'm putting plus to minus, then I'm doing series. So the connector's design and shape allows only for you to make series connection to allow mistakes in the roof level for installers and all that stuff. But for yourselves, the same. Because imagine, string 1 inverter 4. Very good. We know the location. So we make sure that off, put the meter here, no amps, okay, so I can remove this safely and sound. Don't worry, you will not see nothing. No sound will come, nothing, because you have 0 amps, okay? Now you go up, and you find, I have a panel broken there. I need to change this panel, for example. And then I need to disconnect those panels. So when you go there, clamp again before you switch off. Clamp again, okay? Always clamp. Meter, make sure 0 amps. 0 amps, we can open. What I would like you guys to do is just a heads up, we never short the panel by default. So your panel is like this, there is 1 plus and 1 minus. This 1 plus and 1 minus was designed to connect to the other panel and to the next panel. But sometimes people, when they see too many cables in their day or something, or too many connectors, they short these panels they short the same panel, plus and minus they hook. If by any chance this happens at the roof level, all right, you keep it there, okay? Don't worry, nothing will happen. Keep it there, wait for the sun to come down, because no sun, no current, put the clamp, and safely remove it. Okay, guys? Finally, I want to show you here this one. The Igbts I cannot show you now, but they are inside this machine, okay? Okay? Okay, so each breaker is for each one of these machines, all right? And you remember that you have 100 kilowatts, and this breaker is, which size of breaker it is? 200 amps. So we make 150 amps here. We size our breaker for, sorry, I was seeing some red lights. Red lights usually are not good, but these ones are good. So this is a 200 amp breaker. 800 amp breaker. 200 times 4, 800. Then we designed the cables in such a way that the cables can take the power. Okay? So this is the machine I was telling you guys. Okay? You see here, line 1, neutral, 234 volts. Line 2, neutral, 234. Line 3, neutral. Frequency, 49.99. Okay? Imagine now one inverter goes crazy. And instead of 49.99, starts making 55. This machine will know it. The relay one will send an order to trip this one until the conditions are restored. Okay? And if that is not acknowledgeable, then we'll send a second order to the secondary breaker here in the SMDBWH1. Okay? Are you with me, guys? The signal to the other one comes from here. The signal to this one comes from here directly. Okay? So the next session that we're going to have, we're going to force the system to simulate over voltage, over current, blah, 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 and simulate a fault. We will simulate a fault by removing one of these cables, right? Simulating a fault in the system. So what you're going to see is that the inverters will be automatically blinking. You see here? Now it's steady. You have only 3 indicators on this machine. The rest you have to take it from the connection to the computer, okay? If it is blinking, means that is doing the internal checkup prior hooking to the grid. If it is steady, means that is hooked to the grid, exporting. Okay? If it says an alarm, could be multiple reasons, but usually what we do is we hook the computer here, we see the source of the alarm, and then the source will tell us, okay, if it is a DC input, or if it's an AC input, or if something is happening, then we address that problem. Usually could be also inverter problems, machine problems, could be also.
All these problems we can go through the systems.
Exactly. What we usually do is just making sure that our DC side and the AC side is okay. Because if there is no problems on the DC side and AC side, you cannot touch anything here. You see, take, put a new one. And the idea is that, so people don't invent much. Internal setups, you can do different stuff, of course. You can play with it, lead, lag, control reactive, not control reactive, change the setup of the intervals for frequency and voltage. You can play with that. But if it is a malfunction or some hardware problem, then take the machine, put a new one under warranty. Okay? So, and then it says GFI. GFI means ground fault indicator. And usually when this light is up, means that on the DC side or AC side, you are having a fault, electrical fault. Means what? Means that the circuit, for example, the string 10, all right, the string 10 that comes in a particular location on the roof, if it's coming GFI, okay, the inverter will stop by default. By safety procedures, it will stop because GFI means that there is current that is not flowing on the cable, it's flowing somewhere else.
Okay.
So by default, it will open the circuit so the current also stops. All right? So, but GFI can be here, can be at that side. So what the inverter does, since the inverter starts working this morning, all right, the inverter, let's say when the voltage build up here in the channels are enough for the inverter to start, okay, then the inverter will do a insulation resistance test. Imagine if you have a pipe, point A to point B, you want to see a micro leakage on the pipe, sometimes not visual with our eyes, need to measure. So you put a lot of pressure inside that pipe to make sure that there is no small sparkling or whatever. This is the same. The inverter sends up to 1000 volts pressure, all right, and see whatever comes on the other side. If it comes in the same range, means that you don't have a cut in the cable. Know what I mean? And therefore, the insulation is okay, so people can touch here and nothing happens. Are you with me? Clear? But if that alarm comes, means that we have through a passage somewhere. So then what we usually do, we go, this is a fault for you to call someone. Okay? Just register the fault and call us, call someone to help us out. All right? Because could be also, for example, through time, over time, the connectors on the roof may get faulty or something. You know, something could happen. And then this could originate a ground fault. So, in early morning, the inverter makes a insulation resistance. And they register that value. All right? But throughout the day, to make sure that people, the insulation is still guaranteed, what the inverter does is an earth leakage test. And does that every single moment. So the inverter now knows how many amps are coming here. All right, on the positive. He should know how much is taking up on the negative. Okay? He should know that. So if it is on the same value, the earth leakage is okay. If there is different values until a certain threshold, they will indicate there is a ground fault. Again. And that's what you usually call your ELCBs. The same purpose, same idea, but inside the machine. Okay? Any questions, guys? No? Okay. So I think we will remove the loggers when, Ruben, now? Wednesday going to be removed? Or Tuesday going to be removed? One of these days we'll remove this. So therefore we can play with the system a little bit. Simulating the faults, all that stuff. Okay? Making sure you guys can open. Can you have the key there, Ruben? The connectors key? Simulating that you guys can open here the... Yeah, this one, see? You're going to try and open these ones here and there. Give you a few... allow you guys to have some what you call, some techniques that allows you not to spend the full day here, of course, right? There is also some techniques that you guys can understand fast where is the problem coming over. By looking into the computer, you can know, okay, channel 3, where is channel 3? So you focus on channel 3, don't play with the rest, okay? And that's it, guys. Then we will also include the monitoring system. Okay, guys? The exhaust is to the side, so never close these exhausts. If you put your hand here, you'll see that it's pretty hot already. You want to touch? You can touch it, guys, no problem. It's a little bit hot, huh? And the inverter is only working 50% of the capacity. Just for user protection, that what we put is these connectors here. So the female has one and the male has another one. And we just plug it here so to avoid also dust and stuff to go in. Okay. Then you have all the keys. Oh, okay. That's the clamp meter for the Y phase only.
This is John. Only 2 runs. We have 4 runs. So that means around 300 amps per phase.
Yes. Good. And on the neutral, how much current you have? No sei. Possibly. See, this is there is no current flowing on the neutral.